Hello, guys, welcome to a new chapter of The Future of Humanity by Michio Kaku. This is going to be chapter 3 Mining the Heavens. Thomas Jefferson was deeply disturbed. He had just signed over $15 million to Napoleon, a princely sum in 1803, the most controversial and costly decision of his career as president. He had doubled the size of the United States. The country would now extend all the way to the Rocky Mountains. The Louisiana Purchase will go down as one of the biggest successes or failures of his presidency. Looking at the map with its huge expanse of totally uncharted territory, he wondered if he would regret his decision. Eventually, he would send Meriwether Lewis and William Clark on a mission to explore what he had bought. Was it a wilderness paradise waiting to be colonized, or a desolate wasteland? Privately, he acknowledged that in any event it might take another 1,000 years to settle such a vast stretch of land. A few decades later, something happened that changed everything. In 1948, gold was discovered at Sutler's Mill in California. The news were electrifying. More than 300,000 people flooded into this wilderness to seek riches. Ships from all over began to line up at San Francisco Harbor. Its economy exploded in size. The next year, California applied for statehood. Farmers, ranchers, and businessmen followed, making possible the formation of some of the first great cities of the West. In 1869, the railroad came to California, connecting it to the rest of the United States and supporting an infrastructure of transportation and commerce that led to rapid population growth in the region. The mantra for the 19th century was, "Go west, young man." The gold rush, for all its excesses, helped to open up the West for settlement and make all of this happen. Today, some are wondering whether the mining of the asteroid belt could create another gold rush in outer space. Already, private entrepreneurs have expressed an interest in exploring this region and its untold riches, and NASA has funded several missions with the goal of bringing an asteroid back to Earth. Could the next great expansion be in the asteroid belt? And if so, how might we incorporate and sustain this new space economy? One can envision a potential analogy between the agricultural supply chain of the 19th century Wild West and a future supply chain involving the asteroids. In the 1800s, teams of cowboys would herd thousands of cattle from ranches in the southwest, almost 1,000 miles towards cities like Chicago. There, the beef will be processed and sent farther east by train to satisfy demand in urban areas. In the same way that these early cattle drives connected the southwest to the northeast, perhaps an economy could arise connecting the asteroid belt to the moon and the Earth. The moon will be like the Chicago of the future, processing valuable materials from the asteroid belt and shipping them onto Earth. Before we delve further into the details of the asteroid mining, it may be helpful to clarify a few terms that are often confused with one another. Meteor, meteorite, asteroid, and comet. A meteor is a piece of rock that burns up in the atmosphere as it streaks across the sky. The tails of meteors, which point away from the direction of motion, are caused by air friction. On a clear night, you might see a meteor every few minutes simply by gazing upwards. And rock that actually lands on Earth is called a meteorite. Asteroids are rocky debris in the solar system. Most of them are contained in the asteroid belt and are remnants of a failed planet between Mars and Jupiter. If you were to add up the masses of all the known asteroids, the sum would only amount to 4% of the mass of the Moon. However, the majority of these objects would not have been detected by us, and there are potentially billions more of them. For the most part, asteroids remain in stable orbits in the asteroid belt, but occasionally one strays and hits the Earth's atmosphere and burns up as a meteor. A comet is a piece of ice and rock that originates far beyond the orbit of the Earth. While asteroids lie within the solar system, many comets actually orbit in the outer fringes of the solar system in the Kuiper belt, or even outside of the solar system itself in the Oort cloud. The comets we see in the night sky are those whose orbit or trajectory has brought them near the Sun. When comets approach the Sun, solar wind pushes particles of ice and dust away from the comet, resulting in tails that point away from the Sun, not away from the direction of motion. Over the years, a picture has emerged of how our solar system was formed. About 5 billion years ago, our sun was a slowly spinning gigantic cloud, mainly made of hydrogen and helium gas and dust. It was several light years across, a light year being the distance that the light travels in 1 year, or about 6 trillion miles. Because of its large mass, it was gradually compressed by gravity. As it shrank in size, it rotated faster and faster, just as skaters spin faster when they bring their arms in. Eventually, the cloud condensed into a rapidly rotating disk with the sun at its center. The surrounding disk of gas and dust began to form protoplanets, which got larger as they continued to absorb even more material. This process explains why all the planets revolve around the Sun in the same direction in the same place. It is believed that one of these protoplanets got too close to Jupiter, the largest of the planets, and was ripped apart by its enormous gravity, thereby forming the asteroid belt. Another theory suggests that the collision of two protoplanets may have resulted in the asteroid belt. The solar system can be pictured as 4 belts orbiting the Sun. The enormous belt is made up of the rocky planets, which include Mercury, Venus, Earth, and Mars. Next is the asteroid belt. Beyond that is the gas giant belt, consisting of Jupiter, Saturn, Uranus, and Neptune, and finally the comet belt, also known as the Kuiper belt. And outside these 4 belts, we have a spherical cloud of comets surrounding the solar system called the Oort cloud. Water, a simple molecule, was a common substance in the early solar system, but occurred in different forms depending on its distance from the Sun. Close to the Sun, where water will boil and turn to steam, we find the planets Mercury and Venus. The Earth is farther out, so that water can exist in liquid forms. This is sometimes called the Goldilocks zone, where the temperature is right for liquid water to exist. Beyond that, water turns to ice, so Mars and the planets and comets beyond that mainly have water is in frozen forms. Understanding the origin of asteroids and therefore their composition will be crucial for mining operations. The idea of mining asteroids is not as preposterous as it might seem. We actually know a considerable amount about their makeup because of some of them hitting Earth. They consist of iron, nickel, carbon, and cobalt, and they also contain significant quantities of rare earths and valuable metals such as platinum, palladium, rhodium, ruthenium, iridium, and osmium. These elements are found naturally on Earth, but they are rare and very expensive. As the supply of these resources on Earth is exhausted in the coming decades, it will become economically possible to mine them in the asteroid belt. And if an asteroid is notched so that it orbits the Moon, it can be mined even easier. In 2012, a group of entrepreneurs established a company called Planetary Resources to extract valuable minerals from asteroids and bring them back to Earth. This ambitious and potentially highly lucrative business was backed by some of the biggest players in Silicon Valley, including Larry Page, CEO of Google's parent company Alphabet, Inc., and executive chairman Eric Schmidt, as well as Oscar-winning director James Cameron. Asteroids in some sense are like flying gold mines in outer space. For example, in July 2015, one came within 1 million miles of Earth, or about 4 times the distance from the Earth to the Moon. It was about 900 meters across and was estimated to contain 90 million tons of platinum in its core, worth more than $5 trillion. Planetary Resources estimates that the platinum within a mere 30-meter asteroid could be worth $25 to $50 billion. The company has gone so far as to make a list of small nearby asteroids that are ripe for the taking. If any one of them were to be successfully brought back to Earth, it will contain a mother lode of minerals that will pay back its investor many times over. Out of the 16,000 or so asteroids considered near-Earth objects, those who orbit across the Earth's paths, astronomers identified their own roster of 12 that will make ideal candidates for retrieval. Calculations have shown that these 12, each between 10 and 70 feet across, can be coaxed into lunar or Earth orbits with a gentle shift in their trajectories. But there are many others out there. In January 2017, a new asteroid was unexpectedly detected by astronomers just hours before it whizzed by. It passed a mere 32,000 miles from Earth. Fortunately, it was only 20 feet across and would not have caused significant damage if it had hit us. However, it did provide further confirmation of the great number of asteroids that drift past the Earth, most of them undetected. Asteroids are so important that NASA has targeted exploration of them as the first step towards a Mars mission. In 2012, a few months after Planetary Resources unveiled its plan at its press conference, NASA announced the Robotic Asteroids Prospector project, which will analyze the feasibility of mining them. Then in the fall of 2016, NASA launched a $1 billion probe called OSIRIS-REx to meet Bennu, an asteroid measuring 1,600 feet across, that will pass the Earth in 2135. By 2018, the probe will circle Bennu, land on it, and then bring back between 2 and 70 ounces of rock of Earth back to Earth for analysis. This plan is not without risk, as NASA fears that even slight perturbations in the orbit of Bennu might cause it to hit the Earth on its next pass. If it does strike the Earth, it will do so with the force of 1,000 Hiroshima bombs as well. This mission, however, could provide invaluable experience in intercepting and analyzing objects in space. NASA is also developing the Asteroid Redirect mission, which aims to actually retrieve asteroid boulders from space. Funding is not guaranteed, but the hope is that the mission could open up a new source of revenue for the space program. The ARM has 2 stages. First, an unmanned probe will be sent into deep space to intercept an asteroid that has been carefully evaluated by Earth-based telescopes. After conducting a detailed survey of the surface, it would land and use pincer-like hooks to grab onto a large boulder. The probe then will blast off and head to the moon, dragging the object by a tether. At that point, a manned mission would leave Earth, using the SLS rocket with the Orion module. The module will dock with the robotic probe as they both orbit the moon. Astronauts will leave the Orion, access the probe, and extract samples for analysis. Finally, the Orion space module will separate from the robotic probe and head back to Earth, splashing down in the ocean. One possible complication to this mission is that we don't yet know much about the physical structure of asteroids. They may be solid, or they may be a collection of smaller rocks held together by gravity, in which case they will fall apart if we try to land on them. For this reason, further investigation is needed before this mission can proceed. One notable physical feature of asteroids is their highly regular shape. They often look like deformed potatoes, and the smaller they are, the more irregular they tend to be. This in turn raises a question that children often ask. Why are stars, the sun, and the planets all round? Why can't stars and planets be shaped like cubes or pyramids? While small asteroids have little mass and hence little gravity to reshape them, large objects like planets and stars have huge gravitational fields. This gravity is uniform and attractive, and hence will compress an irregularly shaped object into a sphere. So the planets billions of years ago were not necessarily round, but over time the attractive force of gravity compressed them into smooth spheres. Another question often raised by children is why space probes aren't destroyed when they go through the asteroid belt. In the movie Star Wars, our heroes are almost hit by the huge chunks of rock flying around. While the Hollywood portrayal is thrilling, fortunately it does not truly represent the density of the asteroid belt, which is mainly an empty vacuum with occasional rocks passing by. Future miners and settlers who brave outer space in search of new lands will for the most part find the asteroid belt relatively easy to navigate. In these stages of asteroid exploration proceed according to plan, the final goal will be to create a permanent station to maintain, resupply, and support future missions. Ceres, the largest of the objects in the belt, might make an ideal base of operations. Ceres, whose name comes from the Greek goddess of agriculture, which also gives us the word cereal, was recently reclassified as a dwarf planet like Pluto, and is thought to be an object that never quite accumulated enough matter to rival its planetary neighbors. For a celestial object, it is small, about a quarter of the size of the moon, with no atmosphere and little gravity. However, for an asteroid, it is huge. It is about 580 miles across, or roughly the size of Texas, and contains 1/3 of the total mass of the entire asteroid belt. Given its weak gravity, it might make an ideal space station, as rockets would easily be able to land and leave the asteroid, which are important factors in building a spaceport. NASA's Dawn mission, launched in 2007 and orbiting around Ceres since 2015, revealed a spherical but heavily cratered mass, made primarily of ice and rock. It is theorized that many asteroids like Ceres contain ice, which could be processed to extract hydrogen and oxygen for fuel. Recently, using NASA's Infrared Telescope facility, scientists observed that the asteroid 24 Themis was completely covered in ice, with traces of organic chemicals on the surface. These findings add validity to the conjecture that asteroids and comets may have brought some of the original water and amino acids to the Earth billions of years ago. Because asteroids are small compared to moon and planets, they probably will not evolve into permanent cities for colonists. To create a stable community in the asteroid belt would be difficult. For the most part, there is no air to breathe, water to drink, energy to consume, or soil in which to grow food, and there is no gravity. Those asteroids will more likely become temporary quarters for miners and robots. But they may prove to be an essential staging area for the main event, a manned mission to Mars.